All right, so 691. 691 is like the typical problem in our curriculum where they show somebody misusing a concept, and that helps us understand why the concept works the way it does. So Rachel's trying to solve the following system. So we have 2x plus y equals 10 and 3x minus 2y equals 1. It says combine, in other words, add these equations without multiplying either equation. What happened? Well, so let's add them together. We would get 2x plus 3x would be 5x, and then we'd have y plus negative 2y would be negative 1y, and that would be equal to 11. So what happened here? Well, what happened is that we were not able to eliminate one of the variables. We still have both variables. So we were not able to eliminate a variable. Look at me, be careful. There you go. Variable. We still have both x and y, and that's a problem because this is called the elimination method, and it doesn't always work by just adding the two equations together. Okay. Is 2x plus y equal to 10 equivalent to 4x plus 2y equals to 20? You got to stare at it a little bit, but you may realize that this equation just has to be multiplied by 2 to make this equation. Do they have the same solutions? Are their graphs the same? So one thing to try is to put it into Desmos just to verify that they actually have the same equation. They have the same solution. So there's 2x plus y equals 10, and then here comes 4x plus 2y equals 20. And we probably expect them to have the same solution because one is a multiple of the other. And sure enough, as you can see, they have exactly the same solution. They're the same line. Okay, so do they have the same solutions? Yes. Are their graphs the same? Yes. All right. So justify the conclusion with Desmos, we did. How is this 2x plus y equals 10 the same as 4x plus 2y equals 20? Well, simply the second equation is just the first equation multiplied by 2. So when you multiply an entire equation, it doesn't change the value. It graphs exactly the same. So can we use 4x plus 2y equals 20 instead of 2x plus y equals 10? Yes. Why? Because they have the same meaning. So if so, solve the system for x and y. So where originally we had 2x plus y equals 10, we're now going to use 4x plus 2y equals 20. And we're going to solve the system like that. So we'll take that one, make it red, of course. And then we're going to say plus. And then we're going to take this one. And we're going to make it red, and we're going to underline it. And we're going to add these two together. And now, because we actually have the same opposite coefficient for the y's, it'll cancel out, whereas before it didn't cancel, and that's why it didn't work when we first just added them together. Okay, so anyway, 4x plus 3x is 7x, and predictably 2y plus negative 2y is 0, and then 20 plus 1 equals 21. So what we get is 7x equal to 21, so therefore x would be equal to 21 divided by 7, which is 3. So x equals 3. Now we'll just take that x, we're going to substitute the 3 for x in one of the equations. So I'll take this one. And what I'm going to do is I'm going to write it, but then I'm going to replace the x with a 3. So instead of 2x, it now becomes 2 times 3, and then we can solve it. So the first thing we'll do is we'll multiply. 2 times 3 is 6 plus y equals 10. Then, of course, you can subtract 6 from both sides, and you end up with y is equal to 4. So our solution is 3 comma 4. All right, let's just check it really quickly. We should get 3 comma 4 when we graph these two equations into Desmos. So I'll take this one, 2x plus y equals 10, and it's right there. Of course, and then I will take 3x minus 2y equals 1. And we shall look for a solution. Select, oh, there it is. Okay. And the solution is 3 comma 4. 3 comma 4, 3 comma 4. 3 comma 4. We got it. All right. Good job. Congratulations. And on to the next problem.